3 numbers are chosen at random from numbers 1 to 30. Write the probability that the chosen numbers are consecutive. So here given a set of numbers 1 to 30. Say A is equal to 1, 2, 3, and so on, 29 and 30. There are 30 numbers in which the random experiment. So here the experiment we are performing is 3 numbers are chosen at random from set A. 3 numbers are chosen at random from set A. So sample space we can give as number of elements in sample space that is n of s is equal to, out of 30 numbers we are selecting 3 numbers, so that is 30C3. 30C3 is the number of elements in S, and the event in the experiment, one of the subset of a sample space can be taken. The chosen numbers are consecutive, that the chosen 3 numbers are consecutive. So we can write the event as 1, 2, 3 or 2, 3, 4 or 3, 4, 5 and so on, 28, 29, 30. Since our event is chosen numbers are consecutive, the numbers must be consecutive, so we can consider any one of the event like 1, 2, 3 or 2, 3, 4 or 3, 4, 5 or 28, 29, 30. So here clearly we can say that here 28, 1, 2, 3 and so on, 28. There are 28 ordered triads are there. So we can write number of elements in event, that is n of e. So out of this 28 ordered triads we need to select one, that is 28C1. 28C1 is nothing but 28, we can write. So therefore the probability of an event is equal to n of e upon n of s, which is equal to 28 upon 30C3. Since we know that NCR is equal to n factorial by n minus r factorial into r factorial, so we can write 28 divided by 30 factorial upon, which comes the numerator, 30 minus 3 factorial into 3 factorial. So 28 into 27 factorial into 3 into 2 into 1 divided by this 30 factorial, we can write 30 into 29 into 28 into 27 factorial. So we can cancel 27 factorial and 28 gets cancelled. So here 3 2s are 6, 6 5 times. So finally we'll be getting, so 1 upon 29 in 5 times, 25 is 100, 9 5 is 45, so it is 145. So probability of getting 3 numbers which are consecutive, 3 chosen numbers are consecutive, is 1 upon 145. Probability of numbers chosen are consecutive is equal to 1 out of 145, and probability of the numbers chosen which are not consecutive can be can be considered as 1 minus 1 upon 145. That is, it's complementary. That is 145 minus 1, 144 upon 145. So we can consider, as the question is given about the consecutive, chosen numbers are consecutive. So finally the answer is 1 out of 145. Okay. N greater than 3 persons, means more than 3 persons, are sitting in a row. 2 of them are selected. Write the probability that they are together. So here given a set number of persons 1, 2, 3 and so on, n, where n is greater than 3, more than 3 persons are there, and our experiment is our random experiment here, which is equal to 2 of them are selected. 2 of the 9 persons are selected, and hence we can say the number of elements in sample space n of s is equal to, we can write NC2. Number of elements in sample space is NC2, and our event is chosen two numbers or 2 persons are together. So event is chosen 2 persons are together. So we can write the number of elements in an event, which is nothing but, since together means we can consider 1, 2, or from 2, 3, or from 3, 4 and so on, or n minus 1, n. So we had finally 1, 2, 3 and so on, n minus 1 ordered pairs. So we have n minus 1 ordered pairs, among which we can select 1. So we can write n of e is nothing but, among n minus 1 ordered pairs, we need to select 1 ordered pair. Okay, and therefore probability of an event, probability of the event is nothing but n of e upon n of s. N of e is equal to n minus 1 c1 upon n of s is nc2. Let us simplify by using NCR formula. Since we know that NCR is equal to n factorial by n minus r factorial into r factorial, and also we know nc1 is equal to n. So we can write n minus 1 c1 is nothing but n minus 1 divided by nc2, we can write n factorial, and divided with, we can write in the numerator, into 2 factorial into n minus 2 factorial. So further simplifying, n minus 1 into 2 factorial is 2, and n minus 2 factorial divided by n factorial, we can write n into n minus 1 factorial into n minus 2 factorial. So we can cancel this n minus 2 factorial, and then n minus 1 gets cancelled. So we have 2 upon n. So therefore the probability of an event where the 2 persons are selected and they are together is nothing but 2 upon n. A single letter is selected at random from the word probability. What is the probability that it is a vowel? So here the word is given. It's your experiment. Here the random experiment is a single letter, selecting a letter from the word probability. So here total number of letters are is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 letters are there, in which some of them are repeated also, but we consider total number of letters are 11. Out of these 11 letters, we will select 1. That's a sample space. So we can write n of s is equal to, among 11 letters, we need to select 1. And our event in the experiment is selecting a letter is a vowel. Selecting a letter is a vowel. So among the letters probability, so there are certain vowels O, A, I and I. So number of vowels is equal to 4 are there. So selecting a letter is a vowel. So we can say the number of elements in our event is nothing but, out of these 4 vowels we have to select one. 4C 1. So therefore probability of our event selecting a letter from the word probability, which is vowel, is n of e by n of s, that is 4c1 by 11c1. We know that nc1 is equal to n, so 4c1 is 4 and 11c1 is 11, so 4 by 11 is the answer. Okay. What is the probability that a leap year will have 53 Fridays or 53 Saturdays? So we know that a leap year have 366 days, that is 52 weeks plus 2 days. So in which we will have 52 Fridays and 52 Saturdays for sure, because every week we will have Friday and Saturday. So 52 Fridays and 52 Saturdays are for sure. Then remaining 2 days, since we required 53 Fridays or 53 Saturdays, so the 2 days can be, the remaining 2 days can be either Monday Tuesday or Tuesday Wednesday or Wednesday Thursday or Thursday Friday or Friday Saturday or Saturday Sunday or Sunday Monday. So we have 1, 2, 3, 4, 5, 6, 7. So that is sample space, number of elements in sample space is 7, out of which we required Fridays or Saturday, that is, or Friday or Saturday. So Friday is here and Saturday is here. So there are 3 our selection. So that is n of e, or event is nothing but we have to select 3. So therefore probability of the event is equal to n of e by n of s, that is 3 out of 7. So 3 by 7 is the answer. Okay. Three dice are thrown simultaneously. What is the probability of getting 15 as the sum? So when 3 dice are thrown, so the sample space can be considered. One comma 1 comma 1, 1 comma 1 comma 2, and so on, 1 comma 1 comma 6, or 1 comma 2 comma 1, 1 comma 2 comma 2, and so on, 1 comma 2 comma 6. Similarly up so on, 6 comma 1 comma 1, 6 comma 1 comma 2 and so on, 6 comma 1 comma 6, 6 comma 2 comma 1, 6 comma 2 comma 6 comma 2 comma 2 and so on, 6 comma 2 comma 6 and so on. We can write 6 comma 6 comma 1, 6 comma 6 comma 2 and so on, 6 comma 6 comma 6. So totally we can consider that. So here number of elements in sample space is equal to 6 into 6 into 6, that is 2 and 6 or 6 power 3. The total number of elements in the sample space is 260, in which we have to identify the event. Event is sum as a 15. Means when you are thrown 3 dice simultaneously, you will be getting ordered triad in which 3 numbers are displayed. The sum must be 15. So like we can consider, if one number on the dice is 1, the remaining are, if maximum is 6 and 6, 12 plus 1 13, so you are not getting 15. So even if it is 2, if maximum 6 and 6 and the other 2, 6 plus 6 12, 12 plus 2 14, even if you are not getting. So if it is 3, then we can consider 3 and 6 and 6, 12 15. So this is the maximum you are getting. We cannot reduce any number, so we can consider 3 comma 6 comma 6 is one order triad. Similarly, we can consider 4 comma 5 comma 6, because 4 plus 5 9, 9 plus 6 15, and we can write even 4 comma 6 comma 5. Then we can write 5 comma 4 comma 6, and we can write 5 comma 6 comma 4, well, and then we can write 6 comma, and even we can write 5 comma 5 comma 5, 3 5s are 15. So 5 comma 5 comma 5, and then 6 comma 3 comma 6 we can write, or 6 comma 6 comma 3 we can write, and we can also write, I think totally you are getting 1 2 3 4 5 6 7 8, and even we can write 5 comma 6 comma 4, and we can write even 6 comma 4 comma 5, and 6 comma 5 comma 4. So that's it. 1 2 3 4 5 6 7 8 9 10. So total 10 outcomes are there which are favorable. So that is for event. So n of e is equal to total 10. Therefore the probability of an event is equal to n of e upon n of s, that is 10 upon 216. So we can write 5 divided by 108. So 5 upon 108 is the answer. If the letters of the word Mississippi are written down at random in a row, what is the probability that 4 S come together? So here the random experiment. Here the random experiment is arranging the letters in a row. Means it's an arrangement of letters of the word Mississippi in a row, means in straight line. So we can say the number of elements in sample space we can consider to be number of arrangements. So here there are 1 2 3 4 5 6 7 8 9 10 11, total 11 letters are there, in which S is repeating 4 times, I is repeating 4 times, P is repeating 2 times. So the number of arrangements we can consider to be 11 factorial upon, so where s is repeating 4 times, so 4 factorial, p is repeating 2 times, so 2 factorial, and I is repeating 4 times, so 4 factorial. So sample space, number of elements in sample space is 11 factorial upon 4 factorial into 2 factorial into 4 factorial. And now the event is given. So our event in this experiment is 4 s's come together. So we have 4s, so those 4 s come together. Among the arrangements, among these many arrangements, 4 s's will come together. So let us consider this 4 s's as one unit. S as a one unit, and the remaining letters we can write M, I, and then P and P. So total we have the elements. We have the elements 1, 2, 3, 4, 5, 6, 7, 8. So the number of arrangements, where all 4 s's will come together is equal to, that is n of e, which is equal to total 8 factorial divided by, in which I is repeating 4 times, so 4 factorial, and p is repeating 2 times, that is 2 factorial, and then again internally this 4 s's will be arranged inside by 4 factorial by, since all 4 letters are same, so 4 factorial by 4 factorial. That is, number of elements in a event is nothing but 8 factorial upon, so 4 factorial into 2 factorial. Therefore probability of the event is equal to, hence probability of an event P of E is equal to n of E by n of S, which is equal to 8 factorial by 4 factorial into 2 factorial divided by, and number of elements in sample space is 11 by 4 factorial into 11 factorial by 4 factorial, 2 factorial and 4 factorial. So whereby we can also write 8 factorial by 4 factorial into 2 factorial into 4 factorial into 2 factorial into 4 factorial upon 11 factorial. So we can cancel this 4 factorial and 2 factorial. So we can simplify and write 8 factorial into 4 into 3 into 2 into 1 divided by 11 factorial, we can write 11 into 10 into 9 into 8 factorial. So 8 factorial gets cancelled, and here 4 2 times, sorry, so we can cancel here 2 5 times, and again 3 times, so we can write it as 4 divided by, so 11 5s are 55 and 55 3s are 55, 3 times is 165. So we can give the answer, the probability of an event is 4 divided by 165. What is the probability that the 13th day of a randomly chosen month is Friday? So here is an experiment, so random experiment. A month is selected, and then a day. A month is selected and then a day is selected. So our event is that day should be a Friday. So our event is nothing but a day is Friday. So we can generally go with, so first a selection of a month. So out of 12 months we have to select one month. So probability of this event we can consider to be, first a selection of a month, and then means by using multiplication principle and then selection of a day. Selection of month is 1 out of 12. Out of 12 months, 1 month will be selected, and then this 13th day will fall in second week. Second week of month, so that we can consider in second week of a month we'll have 7 days. So that those days are either Sunday, Monday, or Tuesday, Wednesday, or Thursday, or Friday, or Saturday. So we have 7 possibilities. 7 possibilities are there. Out of 7 we have to select one day. So one Friday. So there is only one possibility. So 1 out of 7. So that is 1 out of 12 into 7 is 84. Hence the probability of that the 13th day of a randomly chosen month is Friday is 1 out of 84. 1 by 84 is the answer. Three of the 6 vertices of a regular hexagon are chosen at random. What is the probability that the triangle with these vertices is equilateral? A regular hexagon is a polygon with 6 sides and all sides are equal. So let us consider a hexagon. A regular hexagon, say A, B, C, D, E and F are the vertices. So total there are 6 vertices. So by selecting any 3 points, by taking any 3 points of the 3 vertices, we can form a triangle. So the sample space can be considered. So that is number of elements in sample space can be considered. Out of 6 points, 3 points can be selected, that is 6C3, that is 6 factorial upon 3 factorial into 3 factorial, that is 6 into 5 into 4 into 3 factorial divided by 3 factorial, and here 3 factorial is 3 into 2 into 1. So we can cancel here 3 2s are 6 and here 3 factorial, so which is nothing but 20. So 20 triangles will be formed, but among these 20 triangles there are only, we can say, suppose a triangle is formed by joining AE, AC and then EC, then it will be a equilateral triangle. And one more we can consider from the vertex B joining BF and then joining BD and then joining FD, so we will get one more equilateral triangle. And then if it is considered from the vertex C, again you are getting the same AEC triangle, and from vertex D you are getting again BFD triangle, and from vertex E you are getting again AEC triangle, from F you are getting again FBD triangle. So we can say that from the 2 vertices only we are getting 2 equal triangles. So our event, so number of equilateral triangles from this regular hexagon is, so we can say n of e is equal to 2. So only 2 are equilateral triangles. So there are 20 triangles formed from the 3 vertices, but among these 20 triangles, equilateral triangles will be only 2. So we can say the probability of an event is equal to n of e upon n of s, that is 2 upon 20, which is 1 upon 10. So 1 by 10 is the answer. if E1 and E2 are independent events, write the value of P of E1 union E2 intersection E1 bar intersection E2 bar. Since we know that if E1 and E2 are independent events, then their complements are also independent events. E1 and E2 are independent, which implies E1 bar and E2 bar are also independent. So let us consider the probability. Probability of E1 union E2 intersection E1 bar intersection E2 bar, which is equal to probability of E1 union E2 intersection of E1 bar intersection E2 bar is nothing but E1 union E2 whole bar. Since we know that A intersection B whole complement is equal to A complement union B complement, or A complement intersection B complement is equal to A union B whole complement. So from the De Morgan's law, it follows that E1 bar intersection E2 bar is nothing but E1 union E2 whole complement. And also P of E1 union E2 intersection E1 union E2 bar, that is probability of A intersection A complement, is nothing but it's an empty. We can say A intersection A complement is, it's an empty set. So we can write E1 union E2 intersection with E1 union E2 whole bar is an empty. So we can write P of empty, and we know that probability of an impossible event is nothing but 0. So we can say the answer is 0. If A and B are two independent events such that P of A intersection B is equal to 1 by 6 and P of A bar intersection B bar is equal to 1 upon 3, then write the values of P of A and P of B. Since A and B are independent events, so which implies that A bar and B bar are also independent. By the definition of independent events, P of A intersection B, we can write P of A into P of B, and P of A bar intersection B bar is equal to P of A bar into P of B bar. So we can write, so that is, it is given P of A intersection B is equal to 1 upon 6. P of A intersection B is equal to 1 upon 6. Since A and B are independent, we can write P of A into P of B is equal to 1 by 6. Let us make it as an equation 1, and then P of A bar intersection B bar is equal to, we can also write this as P of A union B whole bar. Since we know that A union B whole complement is equal to A complement intersection B complement, by the De Morgan's law, we can write P of A bar intersection B bar is nothing but P of A union B whole bar, that is 1 minus P of A union B. Since we know that probability of an event plus probability of an event, its complement is nothing but 1. So 1 minus P of A union B we can write, and also we have, by addition theorem, probability of A union B we can write it as P of A plus P of B minus P of A intersection B, which is equal to, since it is given P of A bar intersection B bar is 1 upon 3, So 1 upon 3 is equal to 1 minus P of A plus P of B and minus of minus plus P of A intersection B. P of A intersection B is given 1 upon 6. So we can write 1 upon 3, or we can bring P of A plus P of B here. P of A plus P of B is equal to 1 minus 1 by 3 plus P of A intersection B is 1 upon 6. So LCM is 6. We can write 6 minus 2 plus 1, that is 5 by 6. P of A plus P of B is equal to 5 by 6. And now let us consider P of A minus P of B whole square is equal to P of A plus P of B whole square. A minus B whole square is equal to A plus B whole square minus 4 times of P of A into P of B. By using the property A minus B whole square is equal to A plus B whole square minus 4AB. So we can write here P of A plus P of B, that is 5 by 6 whole square minus 4 times of P of A into P of B is nothing but P of A intersection B, that is 1 upon 6. So which is equal to 25 by 36 minus 4 into 6 again by 6 into 6, that is 25 minus 6 fours are 24 divided by 36, that is 1 upon 36. So which comes P of A minus P of B is equal to square root of 1 upon 36, that is 1 by 6. So by solving P of A plus P of B, P of A plus P of B is equal to 5 by 6 and P of A minus P of B is equal to 1 by 6. By adding both, P of A plus P of A, that is 2 times of P of A, is equal to 6 upon 6, that is 1. So which implies P of A is equal to 1 by 2, and then subtracting both equations, so we will get 2 times P of B is equal to 5 by 6 minus 1 upon 6, that is 4 by 6. So which implies P of B is equal to 2 upon 6, that is 1 by 3. So probability of an event A is 1 by 2. Probability of an event A is 1 by 2 and probability of an event B is 1 by 3. So 1 by 2 and 1 by 3 are the answers. Okay.